Hello all, this is Mr. G and this is our warm-up for today's lesson. So pause the video right here, give this problem a shot, come back when you think you have an answer. We're going over 3, 2, 1, let's go. We got to find the following information for the function f of x equals negative 3.45 times the quantity x plus 1,872 squared minus 0.01. Thankfully, we do not have to graph this. All we have to do is find the vertex, axis of symmetry, etc. We'll get to everything when we get there. So vertex, that's just h and k. So we have to change the sign of what it looks like. H looks like a positive, so we make it a negative 1,872. And the k value is just negative 0.01. We don't have to change the sign of what k looks like. K looks like exactly what it is. The axis of symmetry, that's always x equals whatever the x value of the vertex is, so it's negative 1,872. Now, maximum and concavity, I like to sort of do together, and the a value, the negative 3.45, really tells us whether it's a max or min and what the concavity is. We don't care so much about the 3.45 since we're not graphing it. What we really care about is the sign of the a value. Since it's negative, that means it's going to be concave down. And to think negative, sad, like a frowning face, I know that's stupid, but it helps me remember. So concavity, it's going to be concave down, and the vertex is going to be right there, so the vertex will be and the maximum value will be the y value of the vertex, which is just negative 0.01. Not a very big maximum, but it's a maximum nonetheless. All right, now we just need the domain and range. We know the domain of all quadratics is all real numbers, so we can put all reals. If you prefer set notation, that looks like this, from negative infinity to positive infinity. Yeah, it's not a great infinity, but whatever. Range we have to be careful of. So it's a maximum. So that means it's going to be all reals where y is less than or equal to something. So all reals where y is less than or equal to, what's the maximum value? Negative 0.01. Negative 0.01. And in set notation, that would be from negative infinity to negative 0.01 inclusive. There we go. So we found all this information without having to graph it, which is good because this would be an absolute nightmare to graph. Let's jump into our objective. Today we're doing chapter 4, section 1. This is the last video we're going to be spending on this section, and after today we should be able to write equations of quadratic functions. So in this video, we're sort of going to be going in the opposite direction of what we've been doing so far. So far, in every single video for this lesson, it's been, okay, here's the equation of the quadratic function, now go do something with it. Either graph it or find some information about it without graphing, but we've always started with the quadratic function's equation. Today, we're going to be the ones writing those equations based on some different information. So here's example 1. We have to write a function rule to model the graph. A function rule to model the graph. Now, the phrase function rule, in case you haven't heard that before, that just means write an equation. It's a fancy term for write an equation. So if you ever hear that phrase function rule, make sure you think, oh, that's an equation we have to write. Let me think. Well, it'd be helpful to have sort of a formula, like a starting point here. And whenever I think of a quadratic, hopefully as soon as we saw this parabola, we thought, oh, this is going to be a quadratic. Let's start with our formula. The formula is y equals, or f of x equals, it doesn't matter, a times x minus h squared plus k. That's our vertex form for a quadratic function. And the reason vertex form is going to be so helpful is because they give us the vertex. We have the vertex right in front of us. The coordinates are, let's see, positive 1, 2, 3, 4, negative 1. So it's 4, negative 1 for the vertex. So that means we've got our h and k values. We've got h and k to plug in. Because to answer this question, we need numbers for a, for h, and for k. We're still going to have our x and y in the answer, but we need a number for the other 3 variables here. So let's see. That's going to be y equals, we don't know a yet, but it's going to be x. We know h. It's going to be minus 4 squared. K is minus 1. So we just plug in our h and k values into our function rule, and we're already most of the way there. All we have to do now is find our a value. So tell you what, I'm going to leave a space right here for the final answer, because once we find a, we need to come back to this function and just plug in a. So I'm going to leave a space right there for our final answer. Okay, I guess I gotta erase that now so I can actually write what I want. What we need to do next is plug in our next ordered pair. Because I mean, we already used this 4, -1. We did everything we can do with that, but there's another ordered pair given to us. And those coordinates are, what is that? 1, 2, 3, 4, 5, 6, 7, 2. Now, this is a big skill we need to be good at as we go through algebra and grow in our mathematical careers. Anytime we see an ordered pair, a point, that's an x and a y value that we can plug in. You don't always want to plug it in. It depends on the problem, but it's always an option. Anytime you have an x and y coordinate and ordered pair, those are two values you can substitute in, and that's exactly what we're going to do. I'm going to skip some space, though, so we have some space for the final answer. So instead of y, I write 2 equals, we still don't know a times x is 7, minus 4 squared, minus 1. Now, I want to be really clear about something. I want to be really clear about why this is so much better than that. Here, we had 3 different variables. We had x, y, and a. But now that we plugged in an x and y value that's on the function, we only have one variable, meaning we can solve for a. Anytime we have one variable in an equation, we can solve for it. Let's see what happens here. This becomes 2 equals a times, I think we can do some of this in our head. 7 minus 4 is 3. We square that and we get 9. Minus 1. Then we just add 1 to both sides. Get 3 equals 9a. Divide everything by 9. And get my face out of the way. We get 1/3 equals a. 1/3 equals a. Now we can take that 1/3 and just plug it in to our answer. So the answer is y equals 1/3 times x minus 4 squared minus 1. That's a function rule, an equation that will represent this graph. Let's do one more like this just to make sure we have it. If you want to pause the video here and give this one a shot on your own, that's fine. If you want to work through it with me as you watch the video, that's cool too. Do whatever's going to work best for you. So we have to write a function rule to model the graph. Again, as soon as we see that phrase function rule, we think, okay, we need an equation. So let's start with the only equation form we know right now, vertex form. Y equals a times x minus h squared plus k. Now let's look at the information they're giving us on the graph. We've got 2 ordered pairs here drawn, and one of them is the vertex, which is handy because we're using vertex form. So let's see, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 5, 5. And the other ordered pair, let's see, that's 9 and negative 1, 2, 3, 4. All right. Let's start with the vertex because that's our h and k value. Let's start with the 5, 5 and plug that in first. That becomes y equals a times x minus 5 is h plus k, which is also 5. So we're almost there. We just have to find our a value, and the way we do that is we use our other ordered pair. Remember, anytime you see an ordered pair or point, I want you to think, oh, that's an x and a y value we can plug into our equation. You won't always need to do that depending on the problem, but it's always an option. Again, I'm going to leave a space here for our final answer. Where were we? So we're plugging in y, so that becomes negative 4 equals, we still don't know a, times x is 9 minus 5 squared plus 5. You just take the x and y value from this ordered pair and plug it in. That's what we just did. Now, we just use our algebra skills. We just solve for a. We get negative 4 equals, let me draw a line there to separate that. Where was I? A times 9 minus 5 is 4. Square that, we get 16 plus 5. Then we just subtract 5 from both sides. Get negative 9 equals 16a. Divide both sides by 16, and that is not going to simplify. I'm just going to leave our a value as negative 9 over 16. If you really wanted to, you could write that as a decimal, but I mean, it's not going to be any nicer looking. Let's just leave it as a fraction. For our final answer, we just plug this in. Now, let me be real clear about this. This is not our final answer. They didn't ask us what's the a value. They asked us to write a function rule, to write an equation. So we can't stop here. We have to take our a value and plug it back in. So it becomes y equals negative 9/16, was it? Yeah, negative 9/16 times, then we just copy the rest. X minus 5 squared plus 5, and that is our final answer for example 2. Just one more example to do in this video. And this one, hopefully, as soon as you see this, you think, oh, this one's going to be a little different, and it is. It says a quadratic function A quadratic function can be written in the form y equals a times x plus 1 squared plus k. If the function contains the points 111 and 2, negative 19, what are the values of a and k? All right, now there's a few big differences here. One is they're already giving us sort of a semi-filled in vertex form. They've given us an h value, but we don't have a and we don't have k. So we're trying to find a and k, like the question says. They're still giving us two ordered pairs, a 111 and a 2 negative 19, but there's a pretty big difference between those two ordered pairs and the ordered pairs they gave us in the last two examples. In the last two examples, they gave us the vertex. We had 5, 5 for the vertex and 4, negative 1 for the vertex. But here, they're not telling us what the vertex is, which is going to make our lives a little bit more difficult. But let's remember the key skill we were talking about earlier. Anytime we see an ordered pair, we got to think, oh, that's just an x and y we can substitute in. So let's do that. Let's rewrite this y equals a times x plus 1 squared plus k down here so I have a little bit more space to work. Now let's take our first ordered pair, 111, and plug it in. That's an x and a y. Let's see what happens. Y is 11 equals a times x is 1 plus 1 squared plus k. Okay, that becomes 11 equals 1 plus 1 is 2, and we square that and we get 4a plus k. There's nothing more we can do here because we see two variables. Now, hopefully we remember our algebra skills. If we have two variables, that means we need two equations. So we need a way to come up with a second equation here so we can solve for a and k. Hopefully you're saying to yourself, well, wait a minute. We got the first equation by plugging in 1 point. Let's get the second equation by plugging in the second point. Remember, that's the key skill for this video. If you have an x and y value, you can plug it in, and that gives you something to work with. Let's see what happens. So y this time is negative 19 equals a times x is 2 plus 1 squared plus k. Now we simplify and see what happens. Negative 19 equals 2 plus 1 is 3. Square that, we get 9a plus k. And now we have a system of two variables, two different equations with the same two variables, a and k. It's just a matter of using our elimination skills. Hopefully you're seeing that's going to be that it's going to be easier to eliminate k. We already have a plus k and a plus k. We just have to multiply one of them by negative 1. I'll multiply the green by negative 1. So the blue stays the same. It's going to be, let me show my work over here. 11 equals 4a plus k. The green equation becomes positive 19 equals negative 9a minus k. Let me double check I didn't make a sign mistake there. Positive, negative, negative. Very good. Now it's time to eliminate. 19 and 11 becomes 30. If I'm doing that correctly in my head, equals a negative 5a, and the k's cancel out. Now we've got one variable we can just solve for. It's a one-step equation. Divide by negative 5, and we get negative 6 equals a, and we found our first answer. A equals negative 6. Now to find k, we just take that and substitute it in. Let's plug it into the blue one. I think that's going to be easiest to deal with. So that's going to be 11 equals 4 times our a value is negative 6. Keep that color-coded. And what's the rest of it? Plus k. Simplifying, we get 11 equals negative 24 plus k. Then we add 24 to both sides and get 35 for k. So those are our final answers. Because it didn't ask us for the function rule this time. It just said, what are the values of a and k? So a equals negative 6, k equals 35, and we are finished. Hopefully that all made sense. Here's your homework for tonight. It's page 199, numbers 35 through 37, and page 201, numbers 56. Do your best with these. If you have questions, by all means, let me know. Enjoy the rest of your day.